Okay, welcome to part 2 of my new series on innumeracy. By the way, in the first video, did you notice the mirage or the reflection or the image of a lamp up here? How did that happen? Think about it. Okay, you're probably all familiar with the Rubik's Cube. One of the original manufacturers of this Rubik's Cube claimed that there were 3 billion possible arrangements or positions of the cube. It turns out that is way off. The number is actually less than that squared. That squared, of course, is 9 times 10 to the 18. And apparently the correct number is about 4 times 10 to the 19. I'll leave that up to the author of the Innumeracy book, Professor Paulos, to confirm that. So this brings me to the concept of coming up with a reasonable number for certain things. These kinds of questions are called Fermi questions. When I was involved in the Science Olympics throughout my career, there was a category in the event called the Fermi questions, and students had to estimate various quantities. So for example, let's consider the amount of blood in the human race. Today we have about 8 billion people on the surface of the earth, and each person has about 4 liters of blood in them. I should know because I've donated blood over 200 times. So that's approximately 3.2 times 10 to the 10 liters. Of course, 1 liter is 1,000 milliliters, or 1,000 cubic centimeters, so that's 3.2 times 10 to the 13 cubic centimeters. There are 1,000,000 cubic centimeters in a cubic meter, because there's 100 centimeters in a meter, so 100 cubed is 1,000,000. So if I change that to cubic meters, I get 3.2, wait a minute, is that right there? That's 13, sorry. So that's about 3.2 times 10 to the 7 cubic meters. And then if I consider that to make up a cube, this being the volume of the cube, and let's say the side length is W for width. I won't use L because that might look like liters. Then the width of that cube is the cubed root of 3.2 times 10 to the 7. That'll be in meters. And it turns out that's about 3.2, coincidentally, you might say, times 10 to the 2 meters, or about 0.32 kilometers. So, if the question was, to what depth would that cover the city of Toronto, the capital of Ontario, Canada, what would you get? Now, before we calculate it, make a wild guess. We've got a cube that's over 300 meters to a side, and I'm going to spread it out over the city of Toronto. The city of Toronto has an area about 630 kilometers squared. You can Google that. So if I spread this blood over an area equal to that, what would the depth be? Well, volume of a rectangular box is the area of the base times the height. So if this becomes the area of the base, the area of the city of Toronto, and if this is the volume right there, then if I divide this volume by that area, I can get the height. So the height would be 3.2 times 10 to the 7 meters cubed, which is, if I change it to kilometers cubed, there's 1 billion cubic meters in a kilometer, because a kilometer is 1,000 meters. So that'd be 3.2 times 10 to the negative 2 cubic meters. So if I divide, like I said, this, whoops, that's the volume, sorry. Divide this volume by this area, I'll get the height. So the height turns out to be, you can check on a calculator, about 0.5 meters. I've converted from kilometers to meters, because when you divide kilometers cubed by kilometers squared, you'll get kilometers. But if you make the conversion, it's only about 5 centimeters. Who would have thought it was only that much? Most people probably think it'd be much more than that. So being able to estimate quantities is a very useful skill to have. It comes up all the time, well, a lot of the time, when you're calculating certain quantities. Okay, I'll leave it at that. See you next time.